create function. So what this create function basically does is it will create a new node. It will create a new node like this and assign whatever data you want to insert, assign the data, both your left link and right link, that is left child and right child, it will make it null. It will in create function, insert function only, you will create the links actually, but create function will just assign memory, give the value, and both left and right you are making it null, then return the temp and return this node wherever it is been called. Temp, return temp. This is temp. Okay. So, listening all of you?
Yes, ma'am.
Yes, ma'am.
The next function, insert function. So, in insert function, what we do basically, the next node to be inserted was 5, suppose. So, what we are doing here, insert function. Yeah, here one note is given. Yeah, it will check if new node's data is equal to the root's data. That means if the already existing data, that last 3 values I told 5, 2 was repeated. So it will be skipped because there is no duplicates allowed in your binary search tree. We are skipping it. Okay. Otherwise, if new nodes data, first you will check the value that is stored. Suppose now I want to insert new node 5, next node, first node it is 6, it is there. Next I want to insert the second node, then again we will call the create function. The create function will allocate memory, place the data in its data path, and both left and right links it will make it as null. Now the node is ready to insert. This is our new node. Suppose this is our new node. Root node is what? This 6. Root node is what? 6. New node is what? 5. I'm just writing the values, but address of the root node and address of this new node will be passed as an argument. For ease of understanding and explaining, I'm giving the values of these nodes here. So if the new nodes data is how much? This is a new node now for us. If the new nodes data, or how much is the data in new node?
5.
5. So if this 5 is less than root data, what is the data in root? 6. 5 is less than 6. Is it true?
Yes, ma'am.
Yes. Hence it enters into this if loop, and in the if loop, if root's left child is double equal to null. Is it null? Root, this is our root. Initially while creating it will hold this a temp. Later this is our root. The first node will become our root node. Then if root's left link is double equal to null, and in this case it is true, this is also true, hence it enters into this if loop and says root's left child is equal to new node. That means you are creating a link for your left child. That is what we have done now. We have inserted this new node, that is 5, as a left child for your new node, for your root. For your root, I am inserting 5 as a left child. Suppose after this, again I want to insert one more element. Let me insert some 12. Randomly I am taking, not from the same data. Suppose 12 is to be inserted. So using create function, again we will allocate memory and create a new node like this. Make both left and right as null. After that, you will pass this new node and root. Root is again our 6. Always it starts from root insertion, and 12. If new node's data, that is 12, is less than root's data, which is 6. Is it true? 12 is
No,
less
ma'am.
than 6, false. Hence, it will not enter into this if loop and comes out of the loop and checks the next condition. Next condition, what you are doing, 12 roots data, new nodes data is greater than your roots data. 12 is greater than 6. Is it true now?
Yes, ma'am.
This is true. Hence, it enters into the if loop. In the second if loop, it will enter. Again, it will check if root's right child is null. Is the condition true? What is root? This one, 6. Root's right child, is it null?
Yes, ma'am.
Yes. So what it will do, it will enter into this if loop and we are making roots right child link to this new node. So what I have just made is I have inserted the new node 12 as a right child of 6 because 12 is greater than 6. Getting the point, all of you?
Yes, ma'am.
All are listening, Remy?
Yes, ma'am.
Okay. Okay, anyway, the last one more item I will insert. One more element
Ma'am, you are not audible.
1 minute, 1 minute. Okay, so I will one more element we will insert. One more element we will insert and we will check the thing, trace the code. So you tell me what any value to be inserted. Anyone
10,
integer?
ma'am.
Huh? Pardon?
10, ma'am.
Okay, so you want to insert 10. So when 10 you want to insert using create function, memory will be allocated, data place 10 will be inserted, both side you are giving null. Okay, left and right node, you are making it as null. Then you will start from the root address and the new node is being passed as an argument. If new node's data, that is 10, is less than root's data 6, condition is false. Hence it comes to the second if loop. New node's data is greater than root's data. 10 is greater than 6. Yes, true. So it will enter into the if loop. If root's right child, that is 6, right child is equal to null, but not null because already there is a right child for this root. So it will go to the else part, and you are again recursively calling the insert function. This time what you are passing as an argument for this insert function is the root's right child. That is, this will become your root. Right child will become the root for the subtree because I'm inserting this new element 10 will become the right, left child. It will become a subtree, right? So you are passing the root, this root's left child and the new node as a argument, and again you are calling the function. This time when you are calling the function insert, this insert, what happens, what is the values that is passed is, now root will become 12. That is right subtree, right child will become the root. New node is the same 10. Because we are not changing the new node, just we are changing the root and new node, the value which is to be inserted. Again, the condition will be checked. If new node's data 10 is less than the root data, here root is not 6 this time, please note, because we are recursively calling. 10 is less than 6, condition is true. Hence it enters into this if loop. If roots left child is double equal to null. Roots left child, yes, it is null. Hence, what we should do, roots left child will be linked to this new node. So we have inserted it as a left child. Similarly, if it was greater, it will not enter into this if part and goes to this else part and will be inserted as a right child. Okay. So for the first null, this one, no, first statement, first if loop, when it will work, only once it will work. When you are inserting the first left child and first right child, then this will be, if statement will be true. Otherwise, every time you are calling the insert function to insert either in the left subtree when it is lesser value, or insert at the in the right subtree when it is having greater value. Clear all of you? Insert function and create function. Two functions we have discussed. Clear?
Yes, ma'am.
If any doubt, you can ask me whenever. So, okay. Anyway, the next two functions, search function. The next function is search. Actually, basically what search function will do is any key element or any data which you want to search, whether you want to find element, whether it is present in your binary search tree or element not found. So basically just if root is null, obviously there is no tree is empty. Binary search BST is empty, you will print and exit. Otherwise, using this printf statement, you are scanning a element and storing it in key. Means element to be searched. Enter the element to be searched and store it in address of key. Integer key you have declared here, so you are storing it. Current is equal to root. Again, our search process also should start from root. That's why we are initiating your current to root. Then until your current reaches the leaf node, until current is not equal to null, you will first check if current's data is equal to key. Maybe sometimes the root itself is the element which you are searching for. That is this condition. If current's data, that is root's data, is equal to key, print the element is found in so and so position and exit. Otherwise, you should compare the key value, the element you're searching, no, that value with the roots value, current's data. If it is less, traverse towards the left child and go on checking. Otherwise, else in the sense key will be greater. We have to traverse in the right child and repeat. This while loop goes on repeated until you find the, means until you traverse each and every node either in the left or right. If it is greater, it will just go to the right subtree and go on looking for the elements in its right subtree. If it is present, that is current's data is equal to key, when there is a match found, this condition will become true and it will print the element. Otherwise, go on incrementing, that is link current's left child if it is less or current's right child if it is greater, and while loop will go on repeating. Until when this while loop will repeat? Until current is not equal to null. That means there is a link further, there is a link or there is some nodes below. When it comes to the leaf node and still it is not finding any match for that particular key, then we should come out of the while loop and print that key element is not found. Key element is not found. So this is the search operation. The next is your in order traversal. All three traversal techniques which already we have discussed in class, but still as it is there here in binary search tree. Yeah, initially I was, we were telling when we were discussing, I thought it was not there in lab exercise, but in binary search tree, they have given this, all these three order of traversal. Okay. So just simple recursive function call will be made, as we have seen in the class also. In order, what should happen? First, you have to recursively traverse towards the left child. So all the leftmost child until it reaches the leftmost leaf node of the tree, this in order function is repeatedly recursively called. Once it is coming to the left node, print the data. After left, print the root data, then traverse towards the right child. Left, root, right. So recursively until your tree is not null. That means until you are visited all the root nodes, you are going on traversing towards the left child, visiting all the left subtree nodes. Then you will print your root node. Then you will traverse recursively your right subtree nodes in order. In pre-order, the same way, you have to pass the root as the argument or parameter for the function. Until this root is not equal to null, you start printing the root value. In pre-order, first root should be visited. Hence, you are using printf statement to print the root value. Then recursively apply the pre-order traversal technique to all the nodes in its left child, left subtree, and recursively apply the pre-order technique to its right child. So root, left and right is your post pre-order. The same way post order also.
Excuse me, ma'am.
Yes, tell me.
Ma'am, instead of if root is not equal to null, shouldn't we write while root is not equal to null? Then only it will repeat like loop, ma'am.
No. Why we are giving if statement? It works if it is root is not equal to null. If when this root will be null, when there is no element in your binary search tree. That is, when it is empty, it will become null. If for an empty tree, we cannot traverse, right? That's why we are giving this condition. Otherwise, you can see here, we are recursively calling the function. Hence, it is not required. While statement is not required. You are recursively calling, applying the root's left child. If you might have observed, let me take for the 4 values. Let us do this in order. Initially, root will be 6 when it is being called. So it will enter into this if loop, in order root's left child. So it will traverse towards left and this is our root. Okay, so again your in order function will be called. Okay, and again your function will be called. This time there is no left child for this. Hence it will come out of this and print the data. So 5 will be visited and 5 data value will be printed. Okay, after this root data is printed, it will backtrack because using the stack recursive function, if tower of Hanoi also we have discussed. So that little you have to paper pen, you have to work out. Tower of Hanoi, how we worked out the same way. How this will go back to the function call of its previous value. Then their printf root data will be printed. Again, after printing, in order root's right child. So it will traverse towards the right. Now this will be the right child or which has been root's right. Again, you are calling the function in order. In order when it is called, here it is not null, it is having a link or a child node. So it enters into the if loop. In order root's left child. Again, there is a left child. So hence again, it will come to this left child. After this left child is been traversed, so again in order left child, this will be function is called again. Recursively, we are calling it again. So in order left child, then it will print this data because there is no further links. That is, it is null. Then it will print the data 10. Roots data, it will print. After printing this roots data, what was the function which is called? before calling this node. 12 was a root. So that root value will be printed. As there is no right child, it will not call the function. Means it will call, but as it is not null, it will just simply call and come out. Then it will go to this root and come out of this in order. All the 4 values are printed. It will come out of the in order function. So something like this, recursively function is called. So that if statement means that if there is no further child nodes in for your root, then you come out of this if loop. Got the point?
Yes, ma'am. Thank you.
So anyway, as I was telling and as I usually tell, you have to trace it. How much ever I explain, I shout from here. You have to take paper pen, execute this program first, then trace it. Then only it will, you will have a better understanding. Okay. So anyway, so that is how these all 3 traversal techniques will work out. After that, in main function, actually nothing to discuss much. Actually, main is just a menu driven program. So all using printf, you will give a menu, press 1 for creating, 2 for searching, 3 for traversing and all. Then enter your choice, and using switch case, you will call the respective functions. If it is first case, that is creation, what you are doing, you are entering the number of elements. So using for loop to create new node and insert each time, we are calling using a for loop number of elements, because in question it was given. In question it was given enter n number of elements. That's why we are using this printf scanf statement, and using for loop you are creating a new node. Each time you are calling create function and inserting it. If root is null, make the root as a new node. Otherwise, insert the new node into the binary search tree. And insert function, we have just seen how it works. If it is greater, it will insert in the right side. If it is lesser, it will insert in the left side. Okay. Second one is search. If it is root is null, means it is empty tree. Otherwise, okay. So case 2 is here it is given search, but here they have given traversal. Okay, so we will change this case. Case 3 should be search as per the menu, and case 2 should be the search, and case 3 traversal. Anyway, traversal you are calling pre, post, and in order traversal and displaying it. Search, call the search function, and break, exit is for break. So this is the binary search tree program. Yes, it is lengthy, but not very difficult and all, as you can divide it into functions and try to understand and trace it. So before winding up, but I will just show you the execution. In online editor. Later you can try this. 1 minute. Are you seeing the screen, online editor? Are you able to see the screen, the online editor one?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. So I have pasted it. Let us run the code. So the code is getting executed. Yeah, so it displayed the menu. Now I will give enter your choice 1. Number of elements, let me insert 5 elements. Actually in question it is given, you can use the same elements also, but now I will give randomly. 5 values I told, 5, 4, 3, 6 and 2. Okay, we have entered 5 elements and a binary tree will be created. So can you tell me what are the values? What will be the binary search tree? First element is 5. So 5 will be the root. Next is 4. 4 will be inserted as a left child. 3 also will be inserted as a left child. 6 will be inserted as a right child. And 2 will be, what happened? I think it got stopped suddenly. Let me run it again. So like this, a tree will be getting inserted, right? 2 will become the second node. 2 will be the left child of 2. Like this, the tree will be created. So let me again give the choice 1, 5 elements, 5, 4, 3, 6, and 2. Okay. Now tell me the in order of this. In order. I should not ask, I think, question. Okay. Anyway, in order will be left node, that is 2,
3,
3.
4, 5,
3.
This is our in order, 5 and 6. What is the pre-order? 5,
4,
3,
3, 2,
3,
6.
2. Post order? 2,
2, 3, 4,
3,
6, 5.
4, 6,
6,
5.
5.
So let us just try this now. Traversal we will do. Okay, I will give the option as 3. So the pre-order is 5, 4, 3, 2, 6. In order is 2, 3, 4, 5, 6. And post order, as we have written, the same output you have got also. And if you want to search, again the next function, search an element. Suppose I will give a element 8, which is not there in the tree. Element is not in the BST. If I give some value which is existing, then it will show key element is present in the BST. You can add one more statement. What is the key element also in the printf statement? You can give is element 5 is found or something like that also. Okay, clear with the output also? 4, enter the 4 to exit. Lost connection. Anyway, so this is all about